Alright, so we have our percent foldable. So we're going to start with our is over of, or as I like to call it, part over whole. So is your part, of is your whole. So at Big City School, there are a total of 4,500 students. 90% ride mass transit to school. How many students ride mass transit? So here's the thing about percentages. Is that you always have your is over of or your part over whole, and your percent is always out of 100, or for the most part, it's always out of 100. So we have 90 over 100 equals of 4,500 students. So that's my total of, so this is my students, represents my total students. And this is how many ride mass transit. So I know that 4,500 ride mass transit. So when I cross multiply, I get 100x equals 450,000. Divide by 100. Here's the great thing about using proportion to solve for problems, is that you get x on this side, and when you divide by 100, you can just cross off 2 zeros. So you get x equals 4,050. So that is my answer, 4,050. Okay, on part B, 30% of the girls take band, 120 of the girls take band. Oops, that's not what I wanted. I wanted marker. 30 girls take band, 120 of the girls take band. How many girls do not take band? Okay, so here's a little bit of a tricky question. It's because our part are girls that do not take band. Alright, so we know that 30% of girls take band. So that means 70% do not take band. Okay? So we have 70% do not take band of the 120 girls. So total girls is on bottom, do not is on top. So I know that there's 120 girls bottom, and I know that percent's always out of 100. So I can multiply, cross multiply, and I get 100x equals 12 times 7 is 84. Add 2 zeros, 8,400. Divide by 100. Again, why we love using proportions to set up percents is because 84 divided by 1 is x. So 84 girls do not take band. Is that majority? Yes. Do not take band. Alright, you're going to have to do the next two problems as warm-ups one of the days coming. Alright, so now let's talking about using proportions to convert. So the model problem I'm going to use is that if there are 2.54 centimeters in every inch, write and solve a proportion that can be used to convert 60 inches to centimeters. So my proportion is going to be inches over centimeters. So I know that there are 2.54 centimeters in every 1 inch. And then I know that I don't know my centimeters, but I know 60 inches. So if you notice that I have that one, that one, and that one. So 60 is right there. 1 inch is on top, 2.54 is on bottom. We can cross multiply. We get 1x equals 60 times 2.54, which is 152.4. And so since that equals 1 centimeter, 1x, then we just divide by 1, we get 152.4 equals x. So 60 inches equals 152 centimeters. So you're going to do the practice problem on that one as a warm-up, and then we will go over it together. These are going to be lots of practice problems. Tax or discount. So there are two things such as markup and markdown. So a markup is where you're adding something like tax. Things that add money to your bill. A discount subtracts money from your bill. So on the model problem, how much sales tax at a rate of 5% must you purchase on the computer hard drive that costs $209? So I know that we know that we're looking for sales tax, and we know that sales tax is a percent. Well, percent is always out of 100, right? 5% is always out of 100%. Right? On a computer that costs $229. So I don't actually know my real sales tax. I know the percentage, but I don't know this number right here, which is the money. But I do know that the total cost, cost of the item is $229. So we cross multiply. We get 100x equals 229 times 5 is 11 point, well, remember, we can't do 5%, so we have to do times 5. So it is, oops, I did all my math wrong. I'm skipping ahead. So 5 times 229 is 11,045. Divide by 100. So remember, the trick to dividing by 100 is move the decimal 2 times. So the sales tax, which is your x, equals $11.45. So the purchase of the computer will be sales tax plus your subtotal, right? The cost. So we have to add $11.45 plus $229. So I get 5, that's a 0 right there. 4, 0, 4, to 240.45 is how much he will spend on that computer. So this is called a markup because you're adding, you're increasing. Markup is increasing. Okay, the next one is a decrease. So what is the sales price? So we don't know sales price. So that's my X. On a shirt that originally cost $34.99 if it is 25% off. So we know 25 always goes over 100. So 25 represents our discount. So that's the discount. 100 represents our cost. So $34.99 goes on bottom. X goes on top because we don't know the sales price or the sell discount. That's the discount right there, how much off. So we can multiply those together and we get 875 equals 100x. We divide by 100, divide by 100. Remember again, the trick is just move the decimal 2 times. So you get $8.75 is your discount, or how much you're selling it for, right? So here is why it's called a markdown. Is because you're making it decrease. It's decreasing. So instead of adding it to $34.99, we are going to subtract it. So we take our cost and we subtract the sell or the discount, which is $8.75. So, borrow from the 9, we get 10 minus 5 is 5, 8 minus 7 is 1, borrow from the 3, 14 minus 8 is 6, $26.15. So see how it's saving you money? This one's a fun one, % of change. Alright, and so the way I actually want y'all to remember change, okay, is not, percent of change is your change, it's a proportion of change over original. Alright, so change is always on top, original is on bottom, and then percent of change. What we're going to do is that for percent of change, it's a ratio. So it's the amount of change over the original. So it's a ratio, so since it's ratio, we can do our proportion. So it's change over the original. So when I write my proportion, the percent of change is what I don't know. And percent's always out of 100. So I know the original cost is $82.13. Alright, so the original cost is $82.13. The change, you have to subtract the original and your new one. So since when I subtracted 82.13, 65.70, that gives me 16.43. So the amount of change is $16.43. So I cross multiply and I get 82.13 times my percent, or times x, right, because x is the percent, equals 100 times 16.43, which is 1,643. Divide by 82.13. Divide by 82.13. I can find that my x is 20%. So my percent of change is a 20% decrease. I can calculate that as well with this problem. So in 2000 a stock was $4.50. In 2003 it decreased to $2.50. What is the percent change? So remember, we want percent of change. Anytime it says percent increase, percent decrease, percent of change is always over the original. So to find the change, I have to subtract $4.50 and $2.15. So when I subtract those, I get $2.35. So the percent of change is $2.35. So our change over original, our change is $2.35. Our original, so which was the first one, was $4.50. Equals, we don't know our percent of change, but we know that percent is always out of 100. So I can cross multiply, and I can get $4.50 times x, or 4.50 equals 235. Divide by 450. Divide by 450. You get that the percent of change, or x, percent decrease, percent of change, is equal to 52.2%. So it's a 52.2% decrease. We're going to do lots of problems over this. So if you're not understanding it right now, you will get to understand it during class. Alright, we're going to work through this. We're going to do lots of practice problems over all these percents. The main thing I want to reiterate is that probably the most important part of anything, and I'm going to highlight it in yellow, is labeling your proportion. If you go back, notice that I always label my proportions. Okay, that's how you not can make sure that you are doing them correctly, is that you just follow what your labels are telling you to do.